Good morning students. Our today's topic for discussion is pH meter. In the last class we discussed the different methods for the measurement of pH. Which all are the different methods? Hope you remember. Which all are they? By using indicators, by using pH paper and by using pH disc. Now let's discuss the pH meter. The most accurate method for the measurement of pH is by pH meter. Okay. So what is a pH meter? It is an electrical method for pH determination. It's the most accurate method and makes use of glass electrodes. It's the most accurate method. It makes use of the glass electrodes and the electrical method of pH. It is an electrical method for pH determination. Next, about the principle. It is based on the principle of electromotive force generated between two electrodes due to the differences in H plus concentration. That is, it is based upon the principle of electromotive force. There will be two electrodes and an electromotive force will be generated between these two electrodes due to the difference in H plus concentration. Okay. When we consider only one electrode, if a metal plate, that is if there is only one electrode and this electrode is placed in a solution of its own salt, then from the metal plate ion starts loose into the solution. Okay, and it become negatively charged by itself as compared to the solution. This creates an electrical potential. Okay, if a metal plate is placed in a solution of its own salt, it loses ions into the solution and itself become negatively charged as compared to solution. This creates an electrical potential. Okay, see this image. Here a zinc plate is placed in a solution of zinc sulfate and from the zinc plate, zinc ions will lose into the solution. This will make the plate negatively charged when compared to that of the solution. Okay. So that is what is mentioned here. If a metal plate is placed in a solution of its own salt, it loses ions into the solution and itself becomes negatively charged as compared to solution. This creates an electrical potential. So, if we place two different metal electrodes and these are connected, the difference in the electrode potentials can be measured as electromotive force. Okay, instead of one electrode, if we place two metal electrodes and these electrodes are connected, the difference in the electrical potentials can be measured and it is measured as electromotive force. Okay, it can be calculated as net differences of two electrode potentials. So, if one of the electrode is standard electrode or the electrode with non-potential, the electrode potential of the other can be easily calculated. So, if we know the electrode potential of one, the other's electrode potential can be easily calculated. Okay. If there is a standard hydrogen electrode of non-potential, the electrode potential of unknown electrode sensitive to the hydrogen ion concentration can be measured. So, the electrode potential generated by H plus concentration in an unknown solution is measured against a standard hydrogen electrode potential. That is the basis of the pH meter. So, here there will be two electrodes and these two electrodes will be connected to a potentiometer and the electromotive force will be measured and one of the electrode will have a non-potential and the electrode potential generated by H plus concentration in an unknown solution is measured against the standard hydrogen electrode potential. Okay. So, mainly this pH meter consists of calomel electrode, glass electrode and potentiometer. In early days it is based on the measurement of an standard hydrogen electrode potential, but nowadays this pH meter is made by using calomel electrode, glass electrode and potentiometer. It has got three components. Okay. So, this is a simple diagram depicting the different types of electrodes in pH meter, the reference electrode and the glass electrode. This one is a reference electrode or the calomel electrode and this is a glass electrode and here is a potentiometer. So what is a reference electrode? A reference electrode commonly used as calomel electrode. Calomel means mercury, something related to mercury. It is a mercurous chloride electrode dipped in a solution of KCl. They have a constant electrical potential of 0.1 molar KCl. They have a constant electrical potential at 0.1 molar KCl solution and at 25 degrees Celsius. And they serve as reference electrode. Okay, so the reference electrode used is a calomel electrode, and it is a mercurous chloride electrode dipped in a solution of KCl. They have a constant electrical potential at 0.1 molar KCl solution and 25 degrees Celsius. Okay, next one is a glass membrane electrode. The important peculiar feature of glass membrane electrode is that they are sensitive to H plus ion concentration. They are used as H plus ion concentration measuring electrode, and they consist of a glass electrode whose tip is covered with H plus ion selective membrane. And inside the glass electrode is a silver wire coated with AgCl paste and dipped in 0.1 molar HCl. So in the glass electrode, there will be a glass electrode and whose tip is covered with H plus ion selective membrane, and inside it there will be a silver wire coated with AgCl paste and dipped in 0.1 molar HCl. And other part is the potentiometer. The potentiometer means potentiometer measures the difference in potential between the glass electrode and the reference electrode. So what are the components of a pH meter? It has got a reference electrode, it has got a glass electrode and a potentiometer. Reference electrode used is mercurous chloride dipped in solution of KCl, and the glass electrode contains what? A silver wire coated with AgCl paste dipped in 0.1 molar HCl. Okay, see this figure. The first image is that of the calomel electrode. You can see calomel electrode, you can see mercury in mercurous chloride. Okay, and the solution, the electrolyte solution is here is potassium chloride, KCl. Okay, now see the glass electrode. This is the glass electrode, and here it contains silver chloride wire, the dipped in a solution of 0.1 molar HCl, and the tip of the glass electrode contains a membrane that is sensitive to H plus ion concentration. So the first image is that of a calomel electrode and the second image is that of a glass electrode. Now the modern pH meter has combined electrode and an electronic measuring and display device. Has a combined electrode and it is an electronic measuring and display device. An electrode needs to be dipped in a test solution whose pH is to be measured. Okay, so it has got a combined electrode, and what does this combined electrode means? It has both reference electrode and the measuring electrode, and the pH is calculated as E minus K divided by 0.0591, where K is a constant and E is the measured potential. Okay, so this is a combined electrode picture of the pH meter. Here you can see in the, just see the inner tube, and you can see the silver here, silver in silver chloride wire, and the tip of the glass electrode contain 0.1 molar HCl. Outside it you can see what? External reference electrode. The here external reference electrode dipped in solution of potassium chloride. Okay, so this is a combined combined electrode image of pH meter, which contains both the glass electrode and the calomel electrode. So this is the picture of the modern pH meter. It is there in our lab. Okay, it is a combined picture of the pH meter. Here, this is the what? Combined electrode. It contains both glass electrode as well as calomel electrode, and it is dipped in 250 ml beaker that contain solution. Okay, and it is here is a display unit which will display the pH, and the time is adjusted at 25 degrees Celsius. Okay. So what is the procedure for doing for measuring pH? Okay, first switch on the instrument and take standard buffers of pH 4, 7 and 9 or 10. That is, we had to take a neutral buffer, that is 7, and we had to take an acidic pH buffer with acidic pH, that is pH with 4, and an alkaline pH buffer, that is 9 or 10 pH buffer. And these are taken in 250 ml beaker. And also take unknown solution in another beaker. Okay, another 250 ml beaker. Then first calibrate with the pH 7 buffer. Before doing that, just wash the tip of the pH meter with distilled water and wipe gently with tissue paper, and after that calibrate with the pH 7 buffer. Then again wash and wipe with tissue paper, wash with distilled water and wipe with tissue paper, and then again calibrate with the buffer pH 4 or with the buffer pH 9. We have to calibrate with the buffer pH 4 if we suspect the pH of the unknown solution is of an acidic pH, then use the buffer pH 4. And if the unknown solution pH is suspected to be having alkaline pH, then use the buffer with pH 9. Okay. After calibrating with the acidic or basic buffer, alkaline buffer, then again wash with distilled water and wipe with tissue paper. Okay, then dip in unknown solution after washing and wiping. Okay, so the monitor will display the pH of this unknown solution and note it, and after that again wash with distilled water and wipe with the tissue paper and wipe with tissue paper. Okay, so this is a procedure of doing or measuring pH of an unknown solution. Hope you understood. Okay, so it is the most accurate method for measuring the pH is by pH meter. You should know what is the principle of the pH meter. It is based on the principle of electromotive force generated between two electrodes depending upon the concentration of H plus ions. Okay, you have to know the parts of a pH meter. It consists of what? Calomel electrode, then calomel electrode is also known as reference electrode, then glass electrode and potentiometer. The modern pH meter contains what? Combined electrodes. Okay, then you should know the procedure for doing pH, for doing or measuring pH. Okay, hope you understood. Thank you.